नहीं 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 अभी नहीं. Hello everyone, this is Priyanshu Choubey, Assistant Professor of Suresh Gandhi University. Today we will talk about the soil farming sector, biotech landscape, biotech sector, that control as soil development. Soil forming factors depends on a weathering of rocks and minerals. So let us start from a weathering definition. So weathering refers to a physical distributions and a chemical composition, decomposition of rocks and minerals resulting in the formation of a parent material. It is basically a combination of the transformation and the synthesis or the process of disintegrations and the decomposition of rocks and minerals, which are broadly brought by a physical, chemical, and biological weathering, leading to a formation of a parent material. Weathering of rocks and minerals is caused by a prevailing environment, which mainly occurs near the surface of the earth. Weathering of the bedrocks in the initial stage involves a physical and chemical breakdown of rocks and minerals, resulting into the formation of losses unconsolidated material called apparent material. The soil are formed by the combined action of soil forming factors and process of the parent material. Classification of weathering process of physical weathering and chemical weathering. Uh, and biological weathering. Physical weathering, mechanical process causing disintegrations of the consolidated massive rocks into a smaller pieces under favorable climatic conditions through a various agent like a temperature, water, ice, wind. Agents of physical weathering and their role in weathering is described like is temperature. So general description about the temperature due to a mono mineralic and the polymineralic nature of rocks, differential expansions and the constructions of a mineral occurs owing to a diurnal temperature change, resulting to a peeling of the surface layer from the rocks breakdown to a small fragments. The phenomena is called the exploitation or a onion type of weathering. Example include a exploration in the basalt and the granite. Cold temperature causes the freezing of interpreted water inside of the rocks, which is expanded at 90% in the volume of extract. The pressure of the about 1,465 ton per meter square, resulting in the breakdown of the rocks. Water most pronounced weathering isn't action of the flowing water leads to cohesion of rocks, resulting in the formation of a smaller fragments which are the transported and the deposited at the fur of places. Sedimented loaded water has a time to down's capacity to cut the rocks and hard surface as a result. Uh, Ravines and the valleys are formed. Water carries a huge borders which break into a smaller fragments to a continuous falling in the water with frictions and or abrasions. Ice moving ice or glaciers causes a great deal of a cutting and a crossing of the breakdown on moving glaciers extract term Termitons pressure on the rocks over lower reaches after the melting of ice. This deposit is called a moraine. The huge boulders seen in the Kangra Valley of Himachal Pradesh are example of the glacier movement and the deposition. Wind, an important agent of trans precipitation of the suspended particle also extrude and the abrasion effect, which is more pronounced in the acidic climate. The rounded rocks, mushroom rocks, remain in the Aravallis are the caused by the wind erosion. Poorly granite and the signal granite deposit or the more prone to the wind erosion. Action of the wind as the weathering agent could be prominently seen is the third agent of Rajasthan. So chemical weathering is a decomposition process with the place primary that the junction of the lithosphere and atmosphere called a weathering front. It is lead to alteration and dispersion of the some minerals and the formation of a new secondary mineral. This process is generally dominant in a tropical high temperature and the high rainfall than in arid climate are the governed by the various agents. The rate of the chemical weathering increases with the increasing amount of the dissolved carbon dioxide and the other minerals is in a water. The presence of organic and inorganic acids accelerate the chemical weathering. The chemical weathering has a great role in a conversion of the primary minerals, that is mica and amphiboles, etc., into a secondary minerals, kaolin, morillonite, and vermiculite. It is the most important process in represent to soil formation. Uh, However, its effectiveness depends on the types of the minerals present in the rocks. For example, quartz and responds very slowly to chemical weathering as compared to olivine. The details are penetrating to various chemical reaction involved in the chemical weathering of rocks and the minerals as under first one is solution. The water is and the universal solvent, and it is the solubility action is enhanced with the dissolved carbon dioxide, organic and inorganic acid as a salt in it. Decomposition of rocks depends on the composition of the rock solubility action of the water. For example, halite NaCl is readily soluble in water, whereas solubility of the some silicates minerals like quartz is very slow. In arid region, in arid regions, soluble minerals remain in the rocks as such a various in a semi-arid and humid region. These are completely washed away. Hydration means a chemical combination of a water molecule with mineral to form a new mineral. Hydration reaction occurs primarily on the surface and edges of a mineral grains, but may prevent the entire structure. In a simple salt, due to hydration, there is a swelling and increasing in volume minerals. The minerals lose their luster and they become soft and get readily weathered. These absorb water, expand, and tends to the fall apart. The absorbed water provides a bridge or an entry for the hydronium ions or hydrogen ions to attack the structure. This process is commonly evident in the nature. The secondary minerals like aluminium and iron oxides and gypsum hydrolysis. Hydrolysis is one of the most important process in chemical weathering. This process due to the property of the dissociation of the water hydrogen into the hydrogen ions and hydroxylic ions. It is a type of double decomposition process in which carbon dioxide, minerals, and organic acid-rich water get easily dissociated into hydrogen ions and hydroxide ions, which are chemically combined with a mineral and from a new mineral. Hydrolysis reactions may be considered as a forerunner in a clay formation secondary clay mineral. Oxidation is a combination of oxygen dissolved in water from atmosphere, air, and exposed rock minerals. It is an important chemical reactions occurring in as the well aerated rocks and soil minerals where oxygen supply and the high biological demand is low. Rocks connecting pyrohexane and hornable biota and gluconite and the chloride etc. are the susceptible to oxidation. In a olivine and the ferrous form of a iron gets oxidized to a ferric form. Due to this, the rigidity of a chemical mineral structure, the weakness and the mechanical breakdown becomes easier. Due to oxidation, new minerals are also found. Minerals connecting a manganese and as a manganese and the sulfur as a sulfur dioxide ions are also susceptible to oxidation. Reduction, the process removal of loss of oxygen in a called a reduction. Reduction is a just opposite to oxidation and the occurs where a minerals is a water saturated oxygen supplied in a very slow. The biological demand of oxygen is very high, resulting in a conversion of the higher valent metals to be low valent state, like example ferrous oxide into a ferrous in the presence of the ferric oxide in the system, sulfide are also found, which impart green and blue color to the soil. Lepidochlorides is also found in the condition which impart orange yellow uh, motilus to soil matrix. Under a reduced condition, the oxidation and reduction process are common in the minerals connecting iron, magnesium, and sulfur. Carbon, carbonations in the combination of carbon oxide with the bases when water reacts with carbon dioxide, it gives a carbonic acid, which is the very important agent of chemical weathering of a soil, and minerals are the solubility of calcium carbonate is considerably high than that calcite. Biological weathering is a change brought by a living agent, humus and animals, higher a plant. Higher biological weathering is a change and brought by a living agent, humus and animal, high a plant or plant at their roots and microorganism, which is mainly controlled by a prevailing environment and are responsible for both physical and chemical changes. When mosses and lichen grow on the exposed rocks. They facilitated the deposition of dust, resulting in a higher plants getting a favorable environment to grow. As a result, root of higher plants penetrate inside the rocks and disintegrated them physically. The mosses and lichen growing on a rock's secret chemical adjust which act chemically on the mineral present in the rocks and the tends to form new minerals, borrowing animals movement of animals and the human activity, cultivation, land leveling, construction of the roads and the buildings, railways also facilitated the physical weathering sequence of minerals. Mineral present in the soil, the parent material under various environment conditions differ in the layer. Their degree of weathering generalized sequence of the mineral is ordered to their weathering resistance in other under. What's more resistance Moscovita, more resistance and Moscovita and K feldspar, sodium calcium feldspar, biota and hornblende, the ignite aluminum dolomite and uh, gypsum is a least resistance. This sequence is comparable to a weathering sequence proposed by Goldick in the year 1938. The degree of weathering may vary depending upon the climate and other environment conditions. Soil formation factors is a process, a pathogenic process, most geological process. So upliftment and of mountains and Iceland operate very slowly in the nature, but is the pathogenic process. Although the slow in terms of a human life, but proceed at a faster rate than a geological process to convert the parent material into a mature soil, showing a distinct nutrient ABC. The pathogenic processes are extremely complex and dynamic, involving many chemical and biological reactions and a different process or combination of process operate under the influence of the soil forming factors. The basis of process involved to operation of soil forming process are uh, addition or gain of water, mineral, and organic matter in the soil, loss of the above materials from the soil, transformation of mineral and organic matter mineral materials within the soil, transfer and the translocation of energy and matter. All this promote horizon differentiation by way of the transformation of soil materials, minerals, and organic matters, resulting in the release of soluble salt and carbonates and oxide, silica, clay minerals, and organic acid, and their subsequent translocation with the percolation water and the deposition and the various depth. Classification of the process. So pathogenic process are simply a recognition and a rearrangement minerals and the organic soil constituents in the different layer under the influence of the various pathogenic factor. This can be broadly classified into two groups. First one is fundamental pathogenic groups process in humification, eluviation, also called the immigration and specific pathogenic process. The fundamental pathogenic process are collectively lead to the formation of a number of soil that are the found on the surface of the earth. This process provide a skeleton for the operating specific pathogenic process. In the fundamental process, if If the pattern of a deposition or a removal of the soil material is specific, then these are kept under a specific pathogenic process. A specific pathogenic process can be categorized into two groups: zonal groups. Zonal groups forming zonal group, the soil formation process that are occurring under the prevailing condition, climate, and biosphere. Biosphere also by active factors. These are certain or equilibrium with their surrounding environment and due to course of time. So calcification. This process occur in a arid and semi-arid climate. Process of the precipitation and accumulation of the calcium carbonate after the mobilization from upper soil layers in some part of the profile. Calcification result in the formation of calcic horizon. K. It can be represented by H2O plus a carbon dioxide is equal to carbonic acid insoluble plus 2H CO3 is equal to calcium bicarbonate soluble. Calcium compounds mobilized by the acidification of the water are kept in solution as long as the supply of carbon dioxide is maintained up to a critical level. Below this level, the carbonate are precipitated as white powdery filling in the soil pores. Later on, a soil matrix is converted into an indurated grain having a hard, spiny nodules of a calcium carbonate. Reverse decalcification. Refers of the calcification, that is a process of a removal of the calcium carbonate or calcium ions the soil by a leaching process. That pedolization. The term pedolization divided from a Russian word pedo means under, pod means under, and jol means ash like. A true pedozole are except some reports of pedozole like a soil pseudopodozole from a high altitude area Himachal Pradesh and Jammu Kashmir and northeastern state. Pedozolation is a process of acid hydrolysis. Acid has a favorable factor climate, cold and humid, vegetative acidic nature. And parent material sandy. High rainfall coupled with the sandy present material favorable in sister leaching because cation like sodium, calcium, potassium, magnesium released during a weathering leach out of the profile. The pH of the soil remains below 5.0 due to the leaching of a basis. Under the acidic environment and the cold climate, polymerization of the simple organic acid is very slow due to sluggish bacteria activity. Thus, organic acid either along on the combination with the saxo oxide. Chillate move to low chill layer and deposited by in a B horizon due to increase in bacterial activity. In silica being insoluble at a low pH remains at the upper layer, and the oxides due to higher solubility. Under this condition, we move down to that deposited in the boron horizon, where a slight increase in the pH in country. This polarization in a soil formation process which humus and oxide become mobile leach out from upper horizon. and get deposited in a lower horizon, while a silica remains accumulation in upper horizon. Laterization. The term latera is derived from a Latin word later means a bricks or tile. Favorable factors form or warm, humid vegetation, broad leaves, tropical vegetation, basic nature, parent material, basic parent material that contain high iron and ferromagnesium, mineral pyroxene, amphipoles, and biota and chloride. High rainfall favorable to intense leaching of a basic cation, sodium, potassium, and calcium, but due to a basic nature of parent material and vegetation, soil pH remains alkaline or neutral. Silica being a soluble in alkaline condition leach out the profile, whereas ions and aluminum oxides are released during a weathering remains insoluble and coat the soil matrix and impart a characteristics red color to the soil. In this process, most of the silica leach out and soil wears a relative proportion of iron and aluminum oxides. Such oxide is high in the soil. The laterite oxisol, oxisol and laterite altisol are mainly used for shifting agriculture. Low intensity grazing and the growing plantation crops with adequate nutrient supply. Anthrozoal and the soil forming process. This pathogenic process are more influenced by certain local conditions such as a relief or parent material than a climate and vegetation, hydromorphic and halomorphic and chalky-morphic soil. And jelly means a Russian word refers to a blue gray, gray green clay. Gelination. The process result in a development of a jelly's horizon G in some part of profile due to a poor drainage condition, dispersion land, imprevious or soil parent material lack of variation. Under depleted oxygen condition, iron compounds are reduced to a soluble, whereas from most of the irons exit as iron or organocomplex soluble, whereas from most of the iron exit of the iron organocomplex in a solution or the mixed precipitation of ferric and ferrous oxide, which impart a typical bluish to grayish color to a horizon, distinct mottles to of a yellow of a rusty brown color on a matrix of a gray horizon are are often found where alternate oxidized and reduced condition prevail due due to fluctuation of water table with the season. The reddish mottles contains high amount of irons than the surrounding blue and gray matrix. Salinization The process of accumulation of salt, such as the sulfur and the chlorine and calcium and magnesium, soil in form a silicic origin leading to development of saline soil. The soil is considered saline if EC electrical continuous salinity saturated extract gather zero 4.2 decimal internal pH is more than pH is less than 8.5 and ECP less than 15. These soil are also called a white alkali soil. Contain mostly chlorine and SO4 and calcium, magnesium with less amount of uh, carbonate and HCO3 and sodium. This soil are formed under arid and semi-arid climate when evaporation losses uh, are the most than precipitation salt released during a weathering accumulation soil area having a high brackish ground water dispersion land and a poor drainage condition also lead to the formation of saline soil. If a groundwater followed by a evaporation springs and upward movement of capillary water followed by evaporation result in accumulation of a salt and soil surface in the root zone. Although physical condition in saline soil good due to a presence of calcium causes population, but high osmotic pressure due to excess soluble soil solution, restricted availability of water and nutrient to plant, resulting in a poor growth. Saline soil could be a reclaimed simply by a leaching with a good quality irrigation water. If the leaching is not good, then artificial drain network need to provide a flush out salt from affected. The process of accumulation, alkalization, solonization, the process of accumulation of sodium ion exchange complex of the clay resulting in the formation of alkali, sodic and this soil are also called a alkali contain most of carbonic and hydrocarbonic sodium and the less amount of the chlorine and uh, sulfate and calcium magnesium. All contents in soil solution are the engaged in the reversible reaction with the exchange sites on the clay and the organic matter particles. As the soil solution dries, most of the carbonic and the calcium and magnesium is precipitated in the soil solution much before the sodium. There's a sodium carbonate, which is 100 times more soluble than a calcium and magnesium carbonate. Thus, the sodium remains in the soil solution and its absorption on exchangeable sites, clay and organic matter is increased. The dominate of the sodium and the exchange site causes a dispersion of a clay leading to a poor physical condition of a plant grow increase the soil pH is a more than 8.5. High pH adversely affect the nutrients availability to plant and bring about the solutions dissolutions of soil organic matter, which forms a thin fibrable layer on the soil surface. This is followed by the dark colored clay evaluated impermeable horizons having a typical polymer structure, which is the characteristics features of the sodic soil. The process of a removal of the sodium from exchangeable side is called uh, dealkalization and the solidization. The abandonment, which is the widely used for emulsion of the alkali soil, is a gypsum reaction could be represented as other amendment like element sulfur and the pyrite can also be used. This amendment upon a hydrolysis and oxidation from a sulfuric acid and acidic solubles native calcium carbonate of the soil, which replace the excess sodium from the exchange sites with the calcium or resulting in a reclamation of soil. Paddoturban process mixing of soil materials not by elevation mixing to a certain extent in the evidence in the soil. Most common types of paddoturbation are the paddoturbation, mixing of a solid by an animal, flora, paddoturbation mixing of a soil plant, agri-allipadotermination mixing of uh, curing process caused by swelling and a shrinking of a clay, evidence of a dirty soil. Cytopadoderm is forced crushing only for a jelly soil or a mixing outer due to a freezing and the thawing of a soil materials. If a precipitation having a main soil water momentum will be a downward leaching nutrient downward evolutions of the clay minerals also affected the soil formation process where evaporation and acid precipitation main soil moisture vapor momentum in upward by a capillary action taking a nutrient by towards. Hello everyone, this is Priyanshu Choubey, Assistant Professor of Chemistry and Bihar University. Today we will going to talk about the soil structure. Soil, what is the soil structure and uh, soil aggregates. So let's see what is the soil structure. Soil structure, it is a particular importance in the absorption of the water and the circulation of air. A desirable structure should have a higher proportion of medium size aggregates and an prescribable number of and an appreciable number of the large pores through which water and air can move. Structure of both the B horizon and the A horizon is a very crucial to a proper drainage in infiltration and productivity in soil with a poor structure root penetration in limited, thus the reducing the plant's access to water and nutrients. The structure of the A horizon has received a great deal of attention because of the its relation to seedbed preparation, B horizon potential aeration, water infiltration, overall soil health. So let's see soil structure. The primary soil particles do not exit as um, such in a natural condition, but the bonded together into a large units of aggregates, usually termed as secondary particles. These aggregates formed under a natural condition are called pads. Whereas an irregular shaped coherent mass of soil formed during a tillage operation is called a clod. Soil structure is defined as the arrangement of a primary and secondary soil particle in a certain structure pattern. This arrangement result in information of different sized pores. Therefore, a soil structure may also be defined as the arrangement of the various sized soil pores in certain structure pattern. So now is the important of a soil structure. Soil structure influence almost all the plant growth factors like water supply, retention, aeration, availability of a plant, nutrient, heat, root penetration, microbial activity, and etc. Strong aggregations decreases uh, decrease detachability and transportability of soil particles by water and wind and thus reduce the runoff and soil erosion. Solid structure is useful for a classification of soils. It is affected by a tillage, cultivation, and application of fertilizer, manure, lime, gypsum, and irrigation. Classifications of soil structure. Uh, Soil structure is described and classified based on the types of the type as determined by a shape and arrangement. The class as a differentiated by a size, and third one is the grade as a determined by a distinctness and the durability of pads. So types of structure based on shape and arrangement of a pad. Soil structure is classified as a simple and the compounds, and simple structure, natural cleavage, planes are absent. Simple structure is of two types: uh, simple granite and massive. In granite structure, particles are completely unattached to each other, as in case of a loose sand. And while in a massive structure, particles are the bonded in a large cohesion, non-structured mass. In case of a surface crust, plow pane, and the clay pan. In compound structure, In compound structure, natural cleavage planes are visible with a naked eyes. This shape are individual paired and described according to relative length and vertical and horizontal axis by a shape and their edges. Compound structure is four types of depending upon a shape and their characteristics like first one, types of compound soil structure and their characteristics. Type one is a blocky all shape and characteristics of a blocky, all the three dimensional of a pads are of about same size, providing a shape of a block having a flat and rounded face. These pads are further divided into a angular blocky and the subangular blocky. In the former phase are flat and the edges and corner are sharp, while in the latter phase and the edges are mainly rounded. The blocky structure usually found in a B horizon and promotes good drainage, aeration, and root penetration. Second one is a prismatic. The pads are analogate more in vertical than in a horizontal direction. Given a column-like shape, vertical cleavage planes are the predominant. When the top of pads are relatively angular and flat, is called a prismatic. And when rounded, it is called a columnar. Prismatic structure commonly occurs in subsurface horizon in a arid and semi-arid region, and poorly drained soil of a humid region having a swelling type of clay. Horizontal axis is longer than a vertical axis, resulting the plate-like appearance. Horizontal cleavage planes are predominant. When the pad are s- thick, they are called platy, and when thin are called laminar. Platy structure is often inherited from a parent material and may also be formed due to a compaction of a clay soil by a heavy machinery. Plate structure restricted infiltration and percolation and aeration soil. Spherical pits are roughly spherical and granular and subdivided into a granular and the crumbs. Granular structure is less porous than the thumb due to a low organic matter content. Spherical structure formed by a biotic activity in surface horizon and promotes infiltration, percolation, aeration, and root penetration in soil. Classes of soil structure on the basis of size aggregates. Each type of soil structure is further subdivided into five classes. The size of aggregates is a certainer of quantitative classifications of soil structure. Chorus and sand size aggregates are more favorable for plant growth and very smaller or very large aggregates. So grade of soil structure.